Morty, we've got to turn the project in early.
Oh my gosh, we got Glasses Brian. What universe are we in? I don't even know. It's Glasses Brian here. I'm just gonna say Glasses Brian. But anyways, Maya was bugging me, so I threw out my contacts and I'm out of contacts. So I'm gonna be Glasses Brian for a little bit here. We've got the project. So let's start working on the project. Gonna be a lot of work to get the project done. We might do it in 2 streams here. We're also gonna be doing in-person office hours later today. We can do the project there if people show up, but we're also dedicating Tuesday and Wednesday to doing the project. So if you are free on Tuesday or Wednesday, come by the Milton area. I think we got office right here. If I type office, MuBot will tell us how to get to the office. And come by the Milton area to do the project. My computer was like, the mouse was really fast this morning. We're gonna go and get some projects started in here. See the screen over there, but let's go do the project. Need to do a word of warning before doing the project though. Like do like a huge warning. Warning, I need my blinking screens. Warning, warning, warning. We do have that on, okay. Let's go over here, bring this, and we say 2 all to 3. Starting, or let's say SNEAT 201 project advice / and warnings. All right, let's go do it. Let's go do the project. Here we go. Okay, so my first warning to you is the following. Do not send or receive work from anyone. Now, this includes taking pictures, looking at their work, showing your work, reading it out loud, listening to someone read it, anything else I can't think of. I just mean this, people come up with some innovative ways to be like, I didn't take a picture of their work. I only recorded it in a video. And I'm like, you didn't take a picture. You made a video recording. It's like, where it's like the law says don't take a picture, but you're like, I followed the letter of the law. I didn't take a picture. I did a video recording. And I'm like, no, you're still taking their work. So if anyone asks you for help, like let's say someone says, how do I interpret a histogram? You say, well, what ways do we interpret a histogram? They say, what do you mean? Remember there was 3 ways to interpret it? And they're like, what? And you say, do you have your notes? Do you have the notes from the class under modules? They're like, oh, I gotta go look at those. They're like, yeah, open them up. What are the 3 ways to interpret a histogram? Shape, center, spread. Well, you might just say, eventually you kind of like, you'd be like, shape, help your friends learn, help remember the concepts yourself. Because unfortunately, a lot of times people just read off their work to people and we catch people for plagiarism, and you don't want to fall into that realm. You don't want to be in the realm of, you've read your work off, you've sent your work, you've done something. No, well, good to see you. We're starting the project. So we'll wake up MuBot here too. Do not send anybody your work. Do not receive work. Do not look over work from other individuals. If you feel like you're not doing your own work, you're probably not doing your own work. So don't do that in any way. Even with, and so let's say this, get help from me and SI leaders. Don't write exactly what we are saying. So you're gonna hear me say things, you wanna interpret it in your own way. Don't just verbatim type what I'm typing or say what I'm saying. I will say a lot, and then I just get a lot of people say, well, I wrote what Brian said in the video. The problem is I'll look at the video and I didn't say that, because it'll be 2 projects match at a super high percentage, like 90% sometimes. And they'll be like, oh, we both just followed the video. And it's like, why does every other project look different than yours? Why is your 2 projects the only 2 that match out of 1,400 projects? Like we have 1,400 projects, your 2 are the only 2 that match. Somehow you both watched the videos and came to the exact same way of writing 90% of the project. And they're like, yeah. And somehow you know each other. Somehow you know each other. And yeah, it's weird. Yeah, so here, we'll get to that here in a moment. So I am hopefully, my goal with this, you say, why are you doing this, Brian? Why are you doing this preface to the projects? Why am I doing this opening? To stop one more student from cheating. If we stop one more student, I've saved myself or other instructors an hour or 2 worth of work. Also, a student doesn't have to go to, yeah, don't cheat. And sometimes people don't realize they're doing it. You can't send work to each other. You can't read each other's work. You can't, this is something you do individually right here. It's like you're taking a test. Think of the project like a test. Let me write that. Think of the project like a test. If it would be wrong to do it on a test, it'd be wrong to do it on the project. So here's my last bit of advice. Think of the project like a test. If you think of it that way, that you're doing your own work, it's your own understanding of the interpretations, and you need to be able to do it. And we're here to help. Like the SI leaders are here to help. They give guidance. I'm here to help. I give guidance. But you're supposed to put it into your own words and understand it and interpret it. And I do some interpretations like I am blank percent confident that the true blank is contained in the interval blank to blank. We don't catch anybody for that because everyone's going to have very similar interpretations for confidence intervals. No one gets caught for you wrote the confidence interval interpretation the same. So hopefully someone's calming down there because, oh, wait a minute, Brian has us write it that way. I do. Anything like Mubot will put in the chat right here. We have hypothesis tests and confidence intervals are our basic interpretations we use all the time. It would be tests, but Mubot will put them in the chat. No. I mean, people know each other from like GroupMe's or Discord or anything. People get to know each other. So Mubot just put the interpretations in the chat and you should write them down. Those interpretations you don't get in trouble for because those are the ones we practice and we get ready for. But the other, throughout the whole project, there's multiple parts where you'll be writing your own things. We don't catch anyone for 10, 20%. We also use our own checker. So let me give you this last thing. It's fully transparent. I want to be as transparent as possible. We run the projects through an additional checker and use old projects from the last 10 plus years of Stat 1. So you don't want to use old work. And then let me say this, do not send anyone your work after taking this class. So staving off someone in the future. Don't send anyone your work after taking this class. It's you're facilitating cheating at that point. So you can get in trouble. The syllabus even says it, that if you take the class and then you send someone your work, it's against the UT honor code to take a class and then send someone your work because that person can't cheat unless you send them your work. I mean, someone else might send them the work and then they're cheating because of that person. But do not send people your project after taking the class. If someone says, hey, you took Stat 1, can I get your project? Say, the project, you're not supposed to send it. They say, but I don't know how to do it. You say, I'll sit down and help you. And then you get to review stats. And you're like, why would I want to review stats? And I'm like, everyone wants to review stats. I want to review stats. So let's review some stats. Let's go over here and start reviewing some stats. Okay. So with that, the number one Stat 1 project, the rubric. Okay. The rubric is going to be your number one way to know how to do the project. So please go through the rubric and look at each thing as you're doing it. Early submission, pretty easy to tell if you get the points right here. You submit early, you get the points. Executive summary outlines what is being researched. Is it clear from the start who the project is for and what is being analyzed? 1 to 2 sentences on that. The executive summary should orient the reader who the company is and what they are researching. You could actually write this part of the executive summary to start. I'd probably use 1 to 2 sentences on that. But notice if you're going through your project, think, did I do these objectives and get over here in this highest mark? Once again, if you get your project grade and you don't like it, you can come back to us and say, hey, I think I did that. And I've changed a lot of grades this semester. It's your grades. You get to tell us if you think you did the thing and you should get a better grade. Then we just talked a moment ago, if you watched the previous section, about what should be unique to you. Your executive summaries and future researches are where we catch a lot of cheating. I'm being as transparent as possible because think about this. This is all your own ideas, what was important to summarize, and what are your future ideas, your action items. I get people who change like 1 or 2 words in executive summaries. Student conduct. So don't change 3 words. Don't do that. Don't read anyone's executive summaries. Don't look at anyone's executive summaries. The executive summaries are all your own ideas about who's the company, what are we doing, what are we trying to understand, what were the key findings, how am I going to present those key findings, what are my action items, like the specifics. And a lot of times people don't give clear action items when they give the action items, and you do this at the end of writing your report. Like imagine you're telling someone, go do this now. And if it's vague, if it's like, go look into this, it's vague. We want a clear action item and connect it to the report. So whatever you're researching, whatever you find out, the action item should be clear. Just be inventive. Come up with things, whatever you like. It's your ideas. And remember, don't read anyone else's. You get in big trouble for that. Okay. So here's your data sets. And with the data sets, let's put right here the rubric. We talked about the rubric. So now we're going to put Statu1 project, the data sets. So the data sets are right here. There are 5 data sets. And each data set comes with documentation on it, like diabetes. And you can see right here, description of among women 21 plus from Pima heritage. That is, I believe, an Indian tribe. Please correct me if I'm wrong in the comments. But you can read more about this data set. It's a real data set. All of these are real data sets. It is the tribe right there. That is correct. And you can read about it and understand what the variables are and what they mean, so you can see what you're analyzing right here. Now, you want to download the data and make sure Jump opens up. This is a JMP file, so it will open up in Jump by default, or inside of Jump, go to File, Open. So if you open up Jump right here, we open up Jump, and you go to File, Open. If it is in your downloads, you should be able to open it. You want to go to File, Open after downloading these files, or if Jump is installed, double-clicking the file after it downloads should open the file by default inside of Jump. So read about these datasets, check them out, and use one of the datasets. Now you are going to come up with your own company. So you will pick one of the Jump datasets below, use the dataset to complete the visualizations, create data analysis on the report. Let's go look at it and see how you'll be using it. Instruction file right here. And Noel or anyone, if you have questions, let me know. We're going to go here to the instructions, which can be found right here. We keep it on the Stats1 webpage in case we have to update something. That way it's updated for everybody. And so here we go with the instructions. So you have to include this at the start of the document so we know who you are. There it is. You have been working, now you won't include this prompt. You've been working for this company and you've been chosen to analyze whatever data you're doing. So you get to pick what your company is called. Insert company, you're going to make up your name of your company. It's whatever company you want. What's your company? What are you doing? That's your call. You've been working for 3 years, so you are part of that company. Why do we say 3 years? You're a big part of that company. You understand it. You're not new to the company. So the point of this prompt, do not include it, don't include the prompt, is that you understand you're a key part of the company. Now, I've been working at Nintendo of America for 3 years. And they said, Brian, we want you to analyze Pokemon. And I said, whoa, I get to analyze Pokemon? That's my favorite data set in the world. So you think about this, I've been working for Nintendo of America for 3 years with Reggie Fils-Aimé. He's no longer the president, he should be. We all love Reggie. And they want me to analyze Pokemon data. So I will be doing the Pokemon data set, which you don't have. If it had, when asked to pick our own company, is this a company makeup? Yeah, exactly. So I doubt anyone else will be working for Nintendo of America like me. You can make up a real company, a fake company. It's whatever you want. And great job, Noel, right there. Let's show you some points. That's the point of it. And think about 2 people, because I'll tell you this. People have said things like, I'm working for Knoxville's Best Fitness. And then someone else says, I'm working for Tennessee's Best Fitness. And like, they just changed Knoxville to Tennessee. And then the rest of the report is like identical. And they're like, at Knoxville's Best Fitness, we value blah, blah, blah. And then it's like, at Tennessee's Best Fitness, we value blah, blah, blah. And they'll change like one of the things. I'm like, who writes the exact same? Like everything the same, except for we value character, integrity, and fitness. We value fitness, integrity, and training. And like, why would you're just changing words. We see what you're doing. Don't do that. Don't read someone else's report. Stop it. So with this right here, yeah, just don't. Make up your own company. It can be real or fake. And then analyze what you're analyzing and explain what you're explaining. You can see the lights in my glasses. So I'm working for Nintendo of America, because of course. Executive summary, this is usually done after doing your full report, so we'll come back to it. This section right here was on picking your data set. You will pick one of the data sets that you have right here, read about it via the documentation, come up with a company that you want to work for or that you're making up, and then talk about what you're analyzing and why. And you might have to do this after writing the report. Once again, it's part of the executive summary, but just be thinking, who's my company? What am I doing? And I don't want to give any details, because every time I give details, I'll see a lot of similarities that I might create. Don't use Knoxville's Best Fitness or Tennessee's Best Fitness. Please don't use those. If I say something during this, I think he'll come up with more things than just that. So literally that's what I saw between 2 reports was they just changed. It was like Best Fitness, Tennessee or Knoxville or Chattanooga. They just changed. And then it was 90% similar. And they said, oh no, we totally came up with these ideas independently. And I'm like, weird that you know each other. It's weird.
Wow.
You didn't impress Owen Wilson. Okay, let's start the project here. We are going to start the project, Noel, and we're going to jump straight into one sample Z. So let's mark this. So we need to make our own company, but use the data that's provided correct. You will use the data provided and think of a company that you want to work for that's going to use this data to make decisions. So you will use one of these data sets here, one of these 5 data sets. The documentation describes what the data is. And then the company you make up is the company you're working with these data sets. Okay, let's go over to the one sample Z. So first off, we want to know what a one sample Z is. So just a little bit of a background on one sample Z. One sample Z is the following. It's going to be for an interval p hat plus or minus z p hat q hat over n square root. That's the interval. So that's the interval. And the test is going to be p hat minus p naught over p naught q naught over n square root. To review the notation to help with the test, this is sample proportion. This is Z star, which is chosen by percent confidence, 1.96 for a 95% confidence. We give you that on the test. Pick one of the 5. That is correct. Sample proportion, Z score picked based on percent confidence. And then P hat, sample proportion found by X over N. 1 minus P hat is Q hat, complement of sample proportion. N is sample size. Z score right here is the standardized difference. It's not related to a confidence interval. That is the standardized difference. P hat is the sample proportion again. P naught is the hypothesized null proportion. We assume that is true according to the null. Like if someone says, I believe 60% of students are from Tennessee, then P naught equals 0.6. That's hypothesized according to the null. P naught, once again, is hypothesized proportion according to the null. Q naught, if P naught is 0.6, Q naught is 0.4. They're complements. 1 minus P naught is Q naught. And sample size right here. I'd highly suggest writing all those down and know how to find them in problems. That'll be a huge help for the test. So check out that part. You can review, but that is a one sample proportion. That's what we mean by one sample Z right there. So we are going to pick a categorical variable with 2 levels you find interesting. Identify which level you would consider a success and why your company is interested in that level. Now, before doing this, are we not using a random sample, I think, right? Let me double check. We're not taking a random sample. Oh, we are. Oh my gosh. I need a big warning. Like, take a random sample. Double checking. I was like, I thought we were. You are using a random sample. Let me put it right here. Warning on that. 1903. I don't want anyone not to do this. Stat 201 project. Take a random sample. Okay. Put it in caps so people will not forget. With whatever data set you're using, get a random sample of it of 300 plus the last 2 of your UTID. To do this, we're going to go right here and go to Tables, Subset. Tables, Subset. Under Tables, Subset, you will enter under random sample size 300 plus the last 2 of your UTID. Now, I'm going to pretend mine is 00 at the end, like my UTID is 585800. So then I would put 300 right there. If yours is 585801, you'd put 01. If it's 585858, you'd put 58. We've done this a few times, so I think you know what to put right there. And then you click OK. This is your random sample right now. I would go to File, Save As, and Save As Project Random Sample or something. Just to save it, if you have to redo any work, if you come to my office, I'm like, oh, we need to remake this graphic. The random sample will not be the same random sample if you get another 300, which means your graphics and your results will be different. And remember, don't just get 300, get 300 plus the last 2 of your UTID. I'm pretending my UTID ends in 00. So save it and have it for later use if need be. That way you've stored it and you can turn off your computer and reopen your random sample. So this would be Pokemon random sample, File, Save As. Okay. And on a Mac, go all the way to the top. The bar up there at the Mac is the active bar. Some people on the Mac have said, I can't find it. It'll be all the way there. So now that we have our random sample, let's go back to doing the one sample Z. And let's say I'll put that as overview. And we'll put this section right here. Stat to one project. One sample Z jump work. Okay. So I want to analyze if a Pokemon is legendary or not legendary. Notice how this is 2 levels, and we can confirm this by clicking over here. 2 levels is what that means. Levels are the answers to a question, like class level at UT, which also has level in it, would be generally freshman, sophomore, junior, senior with 4 levels. And you could think of a 5th as graduate student. So that's what class level is. If you think about something like state born in, might have 51, like the 50 states, and maybe not born in one of the 50 contiguous states, or Alaska's not contiguous and Hawaii is not contiguous. 48? Sounds about right. So you could put the levels are the answers to a question that is categorical. That's what levels means. So you can see I can't use name or type 2 because Pokemon has more than 2 levels, 2 answers to the question, what is the type of Pokemon? Legendary is the only one I can use, and you can click this button right here to see the data and to see if it has 2 levels. Be careful, these are quantitative over here. These are not categorical, and only categorical variables, the red ones, can have levels. So this means I am analyzing legendary by default. Let's go to analyze and go to distribution to see how it is distributed on legendary, not legendary. We click on analyze distribution, and then we double click on legendary to make it appear in the Y columns. That means we are analyzing this Y variable of interest. Let's click OK. And now we're going to click the top red arrow, stack, that puts it in horizontal layout. Now don't change the size of your windows. I'm going to show you why in a moment, but click stack. And then we're going to do all the jump work right now, so you don't have to come back to this. We're going to also click this second option right here and go to confidence intervals and go to other. I'll pause on this. This is going to allow us to create a confidence interval other than 90, 95, or 99%. Notice they have to be entered in with decimal format. So when we go to other to make a 96% confidence interval, we're going to type in a 6 here at the end to make a 96% confidence interval. So this makes a confidence interval that covers 96% of the possibilities around what our estimate is. We click OK, and we are done. Now, the reason you don't want to change the size of the box, I'm just showing this as an example, is if you change the size of the box right here, Jump thinks you want this size of a box, not that. Jump thinks you want to reorient your window, so when you reorient it, it doesn't change it for you automatically. So don't change any window sizes till the end. I've seen a lot of people do it. Notice how the window has been misshapen right now. So keep the default window format until you've created all your output, and then you could mess around with the window size. But Jump's like, oh, you want it to be this size, and then you put something else in, window doesn't resize. Interesting thing they did right there. It's probably a feature to like remove auto resize or keep auto resize on. So notice here, what does this output mean? I have 300 Pokemon, of which 275 were not legendary and 25 were legendary. When you see output like this, you should be able to identify what these are in notation. So just quickly going through what these mean, this right here, do a nice light purple, is P hat, Q hat, this is X, this is N minus X, this is N. If we're interested in legendary well, sure, I'll be interested this time in the percent of Pokemon that are not legendary. And this would be the lower and upper bound for the percent that are not legendary. What we're on Project Kaolin, working on the project. Check it out. We're on the 1 sample Z. And we'll go to a new section here in a section, but this is the project. And this is all the notation next to it. If I'm interested in the Pokemon that are not legendary, then the success rate of not legendary is 275. I am 96% confident that the true proportion of non-legendary Pokemon is contained in the interval. 87.78%. Notice how that's the lower bound to the upper bound of 94.39%. I am 96% confident. And I'll have Mubot type it here in the chat. This is one of the things that, of course, you can write out. Make sure to put it where it belongs in your interpretations. But there it is. We get to pick which one we want to focus on, success or not. Correct. I should have picked legendary as a success. You would just change where X and N and X are at. You do not have to mark the notation, but for the test, you should be able to identify. Because think about this. What is X over N? It's P hat. So if you were to go here and do 275 over 300, look at that. If you do 25 over 300, look at that. So that's confirming that those are Q hat and P hat. Once again, we can see the full sample size down here in the corner. 300 was taken as a sample. 275 is going to be the success amount, the X, and then N minus X, which we don't usually talk about that as notation, but that would be sample size minus amount of successes, which would lead to amount of failures. So Teams rebooting, that's weird. And so this is the success rate, the failure rate, the percent of successes, the percent of failures, sample proportion, complement of sample proportion, and the interval to estimate the true proportion of non-legendary Pokemon. I am 96% confident that the true proportion of non-legendary Pokemon is contained in the interval 87.78 to 94.39. Now I want to point this out because there is interpretations on the test. You should write down this interpretation right here. And when you do this interpretation on the test, which it is points on the test, know it, you will say the following. This is where pretty much we're always going to say it. When you do your interpretation of the interval, you'll put your percent confidence right there. Like I said, I am 96% confident. And here you either say the true proportion, true mean, or true difference in means. Now, all data needs context. I need to write context on this. Because notice I just don't say I am 96% confident that the true proportion is contained in the interval. I say true proportion of non-legendary Pokemons. And then this is the lower and this is the upper. I am 96% confident that the true proportion of non-legendary Pokemon is contained in the interval 90 to 94%. I'm just doing it from memory right there. The lower and the upper would be the bounds over here, the lower and the upper. So we'll do that in the blue. The lower and the upper are over there. And then the context is non-legendary Pokemon. So yeah, false. That's good. It's good highlighting. Can I copy this? Maybe I can. And then the 96% confidence should be in a purple. That's close enough. If we get a chance, could we do question 1 of the quiz? Yeah, we can check that out. There we go. That's a good screenshot right there. That's a good understanding of what to do for the interpretation. Notice, or I got to change that purple to be a little more purple. Not the light purple, but the dark purple. More colors. Look at that. I am 96% confident that the true proportion of non-legendary Pokemons is contained in the interval 87.78% and 94.39%. That is how you do interpretations. So notice what we've color-coded here from the output to make it very, very clear what we're doing. So what does this question want us to do on the assignment? We've done all the jump work, I believe, but let's look at what they're asking us. Now, once again, these are the portions I want you to be focusing on and writing and interpreting. That's why I don't write everything out. I just show you how to do a lot of the jump stuff, show you what it means, show you the notation, understand it. I was to pick a categorical variable interested in analyzing, identify which level you consider a success. For me, it was non-legendary Pokemon. And why your company is interested in this, we want to beef up those non-legendary Pokemon. People are saying that they're lame. Those non-legendary Pokemon are lame, and we want them to be cool. And people be like, oh, dude, I got a non-legendary. And someone's like, oh, man, I only got legendary Pokemon. You're like, oh, I'm sorry. Maybe I'll trade you a non-legendary Pokemon. Create a bar chart and frequency table of the variable you choose. The bar chart and frequency table are right over here. Bar chart is the visualization of categorical variables. So categorical variables are visualized with a bar chart. You can see up there, one way to visualize it, and that's the bar chart on the far left. Frequency table is right there, so we've met that requirement. Make sure your bar chart is in horizontal display and the bars have values over them. If you are in dark mode, this is pretty rare these days. It's just not as common. Let me put this video in the chat because we should have a link to it instead. So dark mode. Here it is. I'll link this in the chat. But this is, if you're dealing with dark mode issues, there we go. So this is my video on how to deal with it. So dark mode, I should just put, Mubot should have it. I'm going to give it to Mubot real quick so he might already have it though. Commands. Maybe he does. That way, if anyone asks in the future, he doesn't. Dark mode. Here is how to fix dark mode on a Mac. Okay, Mubot knows about dark mode now. Cool. We can ask him about it in the future, and he'll tell us how to fix it. Anything that I can have Mubot do instead of me looking up videos is usually better than me looking up videos. So we've got all that good to go. Thank you, Mubon. Create a visualization. Oh man, it says any percent other than 90, 95, or 99. Well, you can do any. We'll probably have a lot of 96s, so I shouldn't have done that. Oh, that was the previous assignment you were doing. Well, that's good. We might just get a lot of 96s. Well, you don't have to do 96. I had the previous assignment I had where you did 96 and 95.5. So you can do, just don't do 90, 95, or 99. 96 is all right. But don't worry, just don't copy anybody. We'll probably see a lot of 96% confidence rolls there now. Sorry, Terry. Name and define the 3 conditions needed for a confidence roll for this variable type. Comment on whether your sample passes or fails each condition. 91.1, you could do it. Yep. Probably 98's a pretty common interval, 2.3263. So yeah, you can do 91.1. But once again, we're not going to catch you for using the same percent confidence. It's like use the same confidence, you have the same executive summary. You got to hit upon multiple things. So it's better to use something unique, but 96 it's not a big deal. As The Rock would say. It doesn't matter. Everyone uses 96. It's not a big deal. Interpret to the rear of the confidence roll. We already did that right there. So no, go back and check out our interpretation. But let's talk about the 3 conditions. Now, when it comes to the 3 conditions, what are the 3 conditions to make a confidence roll, Noel? What are the 3 conditions to make a confidence roll? I'll put this section right here. Let's call it the 3 conditions for a confidence roll. Stat 1 project, 1 sample Z, the 3 conditions. So what are the 3 conditions? Well, and then pause is not a condition. Good answers. So pause is not a condition. We pause when we get to the 3rd condition because the 3rd condition depends on the type of data we're working with. So we get to the 3rd condition and we pause because it's always a random 10%. And then pause is a memory technique to say, don't just blurt out the 3rd condition. So pause is not a condition. Pause is just when you get to here and you're about to do the next conditions, notice we're in one proportion, you pause and you say, what kind of data am I working with? And we're working with categorical data. So what would be the 3rd condition for categorical data? You're correct, Noel. It's either large enough N or success failure. And since we're working with categorical data, the 3rd condition will be success failure. Large enough N, or excuse me, nearly normal now. We'll go more into detail on that when we do some t-test stuff. Nearly normal is the new version of it. And there's nearly normal and chi-squared over there on the right. Here's all the conditions for test 3. Nearly normal is for quantitative data. Notice the t-tests are quantitative, and I've got the Q up there, and C. Bivariate categorical will be chi-squared. More on that later. Success failure kind of goes into what we call the expected cell count greater than or equal to 5. So more on that when we get to it, but let's check it out. Did I get a random collection of data? Well, yeah, I mean, think of what we did to start. I don't want to say, but I mean, think what we did. So, it's random. And then also 10%. Now, my data set, and I'll just flat out say it, is probably one of the few data sets I would break the 10% condition for because I probably took way more than 10% of all Pokemon that exist. So I'd say there's a problem with that. And I would say we fail that condition. But up to this point for the projects is cat, it is not proportion large enough N. Large enough N is it would be quantitative is large enough N. And then make sure to remember that, and so here's my suggestion when it comes to the conditions for the test. If I was, that's Darkman. If I was studying for the test, if I was a Stats 1 student, here's what I would do. I would go to this video and I would either recreate it. This is test 3, or you could just be in this video right now and I'll remove off the screen. I couldn't vanish back in the day. I'll go to where I'm not blocking the screen, maybe. There we go. I would go over here and I would take a screenshot of this and maybe reproduce it and write it down. There's the t-test with nearly normal, independent. I'm writing independent means. There we go. Don't take a screenshot of the previous thing. There we go. Everything is filled out now with the 4 conditions for the last 2 tests in the class in intervals. So I would go here and take screenshots. Proportions are categorical. You see prop and cat right there, Noel. That is where success failure is, and random and 10% are for all of these. So I would take a screenshot of this right here and use this to help remember for test 3. I'd also try to reproduce it, put it in my own words, and be able to describe the conditions and know how to check them. So that's what we're going to do right here to check random. Was it a random sample? Yeah, it is a random sample. So, I mean, just talk about that for like a sentence or two. And 10%, once again, my data set probably doesn't pass that because 300 Pokemon is not less than 10% of all Pokemon that exist. Now, you can assume that you're working with large populations because if you're working with people with diabetes, that's a lot of people, or people in general, not just the people with diabetes. Students, all Stat 1 students, all UTK students for a long period of time. So when you think about this right here, my goal with you is to think you should be explaining why you passed the 10% condition. The 10% condition states that you need to sample less than 10% of the population. So it should be pretty clear that your sample size, lowercase n, is less than 10% of your population size, capital N. So make sure to explain that to the reader. Last, we have the success failure condition. The success failure condition can be easily looked at by looking at how many successes and how many failures you have. How many successes do I have? Does anyone know how many successes I have to the exact number? Now, if you remember, the formula is NP hat. Yep. Is there a way we can prove the 10% with values? You have to assume capital N. You'd have to assume what capital N is. What is NP hat here? Remember, NP hat is actually equal to, NP hat is actually equal to X. So you can go ahead and solve it. You could go 300 times 0.916666. So be careful, the extra zero on that. Look at that. It's 275. So mathematically, what I want to point out is NP hat is actually equal to X. So you can just literally look at these numbers, and that's the amount of successes and the amount of failures. And why do we pass or fail this? So why do we pass or fail this? And then you have to do NQ hat is greater than or equal to 10, which is the 25. Why do we pass or fail this? Because not 10% though, be very careful, careful. So this is not the 10% condition though. Be very careful. The 10% condition states that we need at least 10, the 10% condition states that we need to sample less than 10% of the population size. The success failure condition states we need at least 10 successes, at least 10 failures, which is not a percentage thing. So definitely check it out. Remember, success failure is we need at least 10 successes, at least 10 failures. And then the 10% condition is that we have less than 10% of the population is sampled, found by lowercase n over capital N. So my sample size, I don't want to write too much, but write these down, remember them. Yeah, practice these right here, these conditions. And once again, I'm not showing them all, so make sure they're all on the screen if I'm saying here's all the conditions again. So there they are. We have more than 10 successes. We have more than 10 failures as seen by these numbers right here. I don't want to say exact words, but quote the numbers, show the values, make it clear to the reader. If we have more than 10 successes, we have more than 10 failures. That's got it. Let's review and see if we've gotten all the points, because let's check out what we need to write and what the graders will be grading on. So we'll put this section right here and say project 1 sample Z rubric review. Okay, so now we're going to go to the rubric as though we've been writing and talking about everything. And when we go down to the rubric, what do we see first? The grader needs to have seen that I mentioned which thing was the success and went into full detail on it. Good deal. The confidence interval being displayed correctly is going to be shown by giving a screenshot of my confidence interval. So we'll have that right there. Create the visualization and also give the bar chart and frequency table. Name the 3 conditions clearly and describe for each of them if the condition is met or not. And then we clearly did that for the random 10% success failure. So go into detail and give numeric backing, 3 points right there. So interpret the confidence interval. I am blank % confident that the true blanks contain the interval blank to blank. Good deal. Now we have to do a hypothesized value. So let's go right here. Hypothesized value. So if somebody believed that 90% of Pokemon are not legendary, is that a belief that they would be able to sustain? They say, I think only 10% are legendary, 90% are not legendary. So we explain to the reader that it's a common belief that only 10% are legendary and 90% are not legendary. So this is something I didn't do that they're going to grade me on. The hypothesized values clearly explain why it is important to the company, because it's a commonly held belief that, see, don't write commonly held belief. No, someone's gonna be like, it is a commonly held belief. Don't write what I write. Don't say what I say. Think of your own ways of saying it. It is thought to be, or we hypothesize, or our company wants to investigate. There's so many ways, or say, bro, you just said what I said. There's so many ways to say the things that are not verbatim what I say. So I'm always afraid to say too much or write too much down. Don't write what I write. Don't say what I say. Write your own words. So the hypothesis of a two-sided does not equals test explained clearly without using notation. So what a two-sided test is when a company would test whether something is true or not true. The two-sided test for 90% means we believe 90% is true by default till we have evidence that it's not 90%. So 90% is what is believed to be true, and then we would do a test to see if it's not 90%, that does not equals test. So when it comes to hypothesis, they can be less than, the alternative can be less than, greater than, or not equal to. And so we're seeing if it's not equal to 90%. Explain the conclusion your company makes about the test and how they arrive to this using the confidence interval. So what's really great is a confidence interval. You can see if the null value is contained in the interval. And think about what we said right here. If we have a hypothesized value of 90%, that is within the interval. So 90% is believable because we're saying I am 96% confident that the true proportion of non-legendary Pokemon is contained in the interval 87.78 to 94.39. So we would not reject this value. We do not accept it as true because I think we'd have to accept 89 as true. We'd have to accept 91% as true. We like to say we do not reject these values. So that's why I like to use the phrase not reject, because not reject means you cannot show evidence against. So we would not reject those values. We still believe them. If something is outside the interval, we would reject that value. And also, here's the thing too. Notice how it says 1 minus alpha right here, telling you that your two-tailed test was actually done with an alpha of 0.04. That's a fun fact right there. So the test was performed on the does not equals alternative with an alpha of 0.04 because we used a 96% confidence interval. And once again, put any of this in your own words. I've said a lot right here. Don't write what I write. Think about it. Think about, why do I reject something or not reject something? The interval contains possible values of the truth. The truth, we are 96% confident, is contained in this interval. So if someone said, I think 90% is true, you'd say, yeah, this is possible. Sure, 90 is in the interval. So I don't reject that. That's believable. Someone says 91, you say, yeah, I think that's possible. 91's in the interval. Someone says 80% of Pokemon are not legendary. You say, no, I reject that value. 80% is not contained in my 96% confidence interval. I would reject that and have evidence it is not equal to 80%. Does not equals test if it's equal or not equals. So the null for the does not equals test is the true proportion is equal to the hypothesized, and the two-sided is the true proportion is not equal to hypothesized. Okay, Olin, good to see you. Let's throw you some points here, just watching. But that's explaining the full hypothesized value. And we did the review. I'm just going to call this hypothesized value, but that was a deep dive, almost a whole chapter review. So I hope people use this to also study and remember the topics. We might have just enough time to do a little bit of the one sample T. We're not going to have enough time to do the other one. I love points too. Let's throw big points there. So here comes the one sample T. That is everything. Okay, so let's do the one sample T. Let's do theory on it first and then jump work. Woo woo. Okay, so we're gonna do a little bit of the one sample T. We might be able to get a good bit of it done. We will not be able to do regression in this video. So check out the next office hours. Project one sample T overview. So the one sample T, let's talk quickly about what the notation is for it. It's going to be very similar to the one sample Z. So I'm going to do it on another page right here so you can see what the one sample T looks like versus the one sample Z, and we can kind of compare them. So when it comes to the interval, which gives estimates of what the truth might be, we have the following formula. You have y bar plus or minus t star with n minus 1 degrees of freedom, s over square root of n. This would be your sample mean of the variable y. Just like you collect a bunch of heights, you average them out, that's what that is. T star is the T statistic that comes from a T distribution related to the percent confident we are. So at about 100 degrees of freedom, you have a 95% 1.98, and it approaches 1.96 for the T as you get more degrees of freedom. The degrees of freedom are notated as n-1. So if you have a 101 sample size, 100 degrees of freedom, that determines the shape of the T, which becomes more normal as the T gets more degrees of freedom. So the tails are really thick with low degrees of freedom, and then the T rises up and gets more like the normal distribution with higher degrees of freedom. S is the sample size, or excuse me, S is the standard deviation of a sample. So when you look at the variation, how spread out it is, that is a measure of standard deviation from a sample, comes from also the sample size of the sample. If we sample 101 individuals, and the spread measured by standard deviation is equal to whatever S is, which is a metric of spread of data standardly deviating from the mean. You do not calculate S in this class by hand. The test for a t-test is going to look the following way. It's going to be y bar minus mu naught over S over square root of n. Now, when you look at these tests, it's always going to be a difference divided by some sort of standardizing factor. So we have a standard on the bottom to standardize it, and this is going to be equal to a t with n-1 degrees of freedom. Now, be careful. This is not a t you pick based on percent confidence. It's a difference standardized. Same thing for the other test down here. You'll notice the top of the equation is a difference, the difference between the sample proportion, and then dividing it by the standard deviation of p hat. So that is a standard deviation. It's based on truths. This one is technically the standard error. So let's write that down here. S over square root of n is equal to the standard error of y bar. You might see it just down here on the bottom instead called SEY bar. I hate when people notate it that way. We do it every once in a while, but I prefer it in its full format where it's not written as a notation, S over square root of n. What these are, once again, will be T is the standardized difference you find by taking the difference, dividing by the standard error of y bar. N-1 is the degrees of freedom telling you the shape of the T. Y bar is what you observe in the sample data, the mean of sample variable y. Mu naught is whatever you hypothesize to be true, so you believe people are 70 inches tall. So mu naught equals 70. It's just a belief you hold according to the null. Standard deviation is going to be the standard deviation of a sample, and n is going to be the sample size by which you take, like 101 individuals were sampled. And notice the similarities between these, where the interval has in it a margin of error and also has an estimate, just like this one down here. And the tests have the similarity where the top of the test is a difference, and the bottom of the test is going to be the way we standardize that difference. So hopefully you notice tests are standardized differences where confidence intervals are estimates with margins of errors. Confidence interval estimates that the true mean is equal to y bar plus or minus the margin of error, and then tests are going to be standardized differences. And I do want to point this out that we always like to show this because a lot of people get confused on this. These values right here, we'll go with the purple. Those values are not the same. I don't know how to show it other than just being like, these are not the same. The Z down below is the standardized difference. The Z here, we put a star on to say we pick it just based on percent confidence, just like this T has a star where this one doesn't. The T up top is based on a percent confidence where you say like, I'm 96% confident. Let me choose the T that relates to that. That T down there is the standardized difference, which is then used to find a p-value. Practice those. A lot of people think, wait, I just take this T and plug it there, or take this T, plug it there. No, they're different. Used for different things, to make a confidence interval or to run a test. Okay, dokie, that's the overview. Let's start doing some of the jump work on Pokemon data. It's like a 5-minute lecture on it. Yep, in-person office hours. Yeah, we're gonna do a big Tuesday and Wednesday pure office hours on. I'm gonna tell my classes that Tuesday and Wednesday, 100% of the office hours in person will be for the project. So swing by. And Monday too. You can come by any day, but Tuesday and Wednesday, all project all day long. I'm gonna tell the honors class today that I'm just doing project those days. So what we have to make now is we have to make a confidence interval, and let's go to the project. Here's the instructions. And we don't want to do a regression yet. We're going to do one simple T. Pick a quantitative variable you're interested in analyzing. So I want to analyze the attack power of Pokemon. That's quantitative. How do you know it's quantitative? It's going to have a blue on it right here. Blue means quantitative, so make sure you got a blue one. And then create a histogram, make sure it has a count axis and is in horizontal layout, include a screenshot. Did not add the counts on the bars. Oh, you forget one thing. Might need to tell Terry. Noel, I forgot one thing. One button click. Counts. And then show counts. It's not that big of a deal. It shows the counts there. I'm gonna tell Terry. Be like, Brian goofed in his video that a lot of students are gonna watch. I don't know. I always add it for the other one. I don't want students to lose points. It's a bummer. Need to like, maybe I'll edit the video and put, it's hard to edit these videos though sometimes. What's it say on the rubric for that? It's the creation of the graphic we're looking at. Visualization. See, they can't hit you with that many points. Yeah. That might be a point, but I hate thinking I lost you even a point. I hate thinking that. Send an announcement, but hopefully you're watching this video right now. This is why you can keep this up, and you can just literally click the drop down arrow right there and go to histogram options, count access. You don't want to add it to the next one we're about to make, so very sorry. Let me put the note right in here. I'm gonna add a note to the video that might help people. And Statuum project. Okay, so I've added a major check. You're clicking the timestamp maybe, and you see this. Please make sure if you're doing your project, you go to your data you created right here for the previous thing, and you might need to reload it, just recreate the graphic, and you might only need to create this right here. Let me show you the steps. So what you'd want to do is if you don't have the graphic up, you want to go to Analyze, Distribution, double-click the categorical variable of interest, click OK, and then click Stack, then click the second red arrow, click here on histogram options, click to count axis, second option, histogram options, and then go to show counts. So you want to have count axis and show counts clicked, and you could even expand this a little bit right here. And then you want to create your interval. Remember, you can create any interval of your choosing other than 90, 95, or 99. So you could go in here and choose something like 98, and there you go. So make sure you're showing the counts and the count axis. Just kind of put both on there just in case. And we're going to finish off with some jump work right here, showing how to do jump work over here. So let's go. I'm going to put a new timestamp, just enough time to show how to make the output for the one sample T. Jump output, jump work. Okay. So the one sample T is for quantitative, as we've been seeing. So you need to go to Analyze, Distribution, and then under Analyze Distribution, you need to double click a quantitative variable, make sure it's blue that you wish to analyze. Double click, and now click OK. Look at how it should look. Analyze Distribution. You're going to click the top red arrow and click Stack. Then you're going to click this arrow right here and go to histogram options and go to count axis. Don't add the counts on top of it. I know I just showed an update on what to do, but the counts on top of this one's not as important as the counts are on top of a bar chart, because bar charts for categorical data where we want to look at the counts. I believe now we'll finish off the jump work of this section. We are also creating a confidence interval. There's the interval interpretation and hypothesized value with this right here. So let's double check. We are using the conf once again for that. Very similar work is being done right here. And let me double check, because you can create any interval you want, I believe, for this. So let's double check the one sample T. and provide a short write-up explaining, nope, that's a different part of it. Create your confidence interval. Don't choose 90-95. We're only doing the jump output right now. So with this, you click right here, go to confidence interval and go to other and pick something other than what I pick. Try doing that. You don't want to pick 90, 95, or 99. And then you click right here, punch in something other than 90, 95, or 99. Make sure it has the dot and click OK. And there you go. I would do this in 2 screenshots where I would screenshot this over here, this portion, and then I would screenshot my confidence interval. So I'd wait to do the confidence interval screenshot till I start interpreting the confidence interval section. Notice you get the 95% confidence interval there, and I picked a 98, so it is wider, going from 76.56 to 85.5, versus the 95 is only going from 77.27, not as wide, to 84.799. 79967. Only 2 decimals, I would say, on this. And so we will be back tomorrow to do more interpretations and more practice, and probably, so if you're watching this video, to be concluded tomorrow. But thank you everyone for being here. We've done a full deep dive into the project. It'll take 2 streams to do this, but this is how to get the jump work done. And we'll start next time with doing the jump work again. And we'll probably be able to do everything. I'm also trying to do a little mini lecture for each one, an overview, like a 4 to 5 minute overview. Well, that's got it. Bye for now, everyone. Bye, Noel. Bye, Keolin. Bye.